Good evening, I am SIDDHARTH Sharma from Arya College of Engineering IT from Department of Mechanical Engineering. I am presenting lecture on layout and working of steam power plant. These are the content, that is introduction of steam power plant, layout of the steam power plant, Rankine cycle on which steam turbine is working, then advantages and disadvantages. Steam power plant works on a steam Rankine cycle. Steam is produced in a boiler and it is expanded in the prime mover, that is steam turbine. Condensed steam is fed back into boiler again. A alternator is provided to generate electricity which is driven by the steam turbine. First of all, water is coming into the boiler and it boils and converted into steam. This steam is supplied to the turbine, and by the movement of the turbine, electricity is generated by the means of different devices. This is the general layout of a steam power plant. We can see in steam power plant there is a ash handling system, air heater, low power heater, boiler and economizer, high power heater, boiler feed pump, fuel, turbine, condensed with water pump, circulating water pump, cooling tower and alternator. Alternator is attached with the turbine, and basically what happening, water from the steam from the boiler come into the turbine, then from turbine it comes to the condenser. With the help of condensed water pump, it comes to the high power heater, then then into the boiler feed pump, then low pressure heater, then again in boiler. This completes the cycle. Ash handling system and contains the ash during the generation of electricity. Fuel is supplied to the boiler for the running of the boiler. Alternator is provided to convert the energy into electrical energy. Cooling tower is used for cooling of the whole power plant. So this is the layout of a typical steam power plant. In this section, we will discuss one by one about the part which we have seen in the previous slide. The schematic arrangement of a modern steam power station can be divided into the following stages, that is coal and ash handling plant, then steam generating plant, and steam turbine, alternator, feed water and cooling arrangement. So what happened in coal and ash handling plant? Coal is transported to power station by rail or road and stored in coal storage plant and then pulverized. Pulverized coal is fed to boiler by belt conveyors. Coal get burned in the boiler and ash produced is moved to the ash handling plant and then delivered to ash storage plant for disposal. In steam turbine, dry and superheated steam from superheated is fed to the steam turbine. The heat energy of steam when passing over the blades of turbine is converted into mechanical energy. After giving energy to the turbine, the steam is exhausted to the condenser, which condenses the exhausted steam by means of cold water circulation. In alternator, what happens? Steam turbine is coupled to an alternator, as I told in the layout of the steam power plant. Alternator converts the mechanical energy to the electrical energy. The electrical output of the alternator is delivered to the bus bars through the transformer, circuit breakers and isolator. What happen in steam generating plant? The steam generating plant consists of boiler, superheater, economizer, air preheater. What happen in boiler? The heat combustion in the boiler is utilized to convert water into steam at high temperature and a pressure. Superheater, what the steam produced in boiler is wet and is passed through a superheater where it is dried and superheated, increases efficiency. Economizer, it is essentially a feed water heater and drives heat from the fuel gases. Air preheater increases the temperature of air supplied for coal burning by delivering heat from fuel gases. Air is drawn from the atmosphere by the forced draught fan and is passed through air preheater before supplying the boiler furnace. This is the ideal Rankine cycle on which steam power plant is working. On the left hand side we can see the schematic arrangement of a steam power plant, and in the right hand side we can see the Rankine cycle on which steam power plant is working. Steam power plant contains pump, boiler, turbine, and 1, 2, 3, and 4 point are marked on the left hand side and as well as right hand side. So what happened in one from 1 to 2, 2 to 3, 3 to 4 in upcoming slides. Process 1 से 2, water from the condenser. A low pressure is pumped into the boiler at high pressure. This is reversible adiabatic process. This is reversible adiabatic process. Process 2 to 3, water is converted into steam at a constant pressure by addition of heat in the boiler. Process 2 to 3, water is converted into steam at a constant pressure by addition of heat. Process 3 to 4, this is reversible adiabatic expansion of steam in the steam turbine. Then process 4 to 1, constant pressure heat rejection in the condenser to convert condensate into water. Now we will discuss the advantages of steam power plant. They can respond to rapidly changing load without difficulty. It can be located very conveniently near the load center. These plants can be set up near the industry. Transmission costs are reduced. Steam engine and turbine can work under 25% of overloaded continuously. These are the disadvantages of steam power plant. Maintenance and operating costs are high. The cost of plant increases with increase in temperature and pressure. A large quantity of water is required. Presence of turbulence due to smoke and heat in the plant.